Hello, everybody. Good morning. My name is Beth Yates, and I'm the Children's Consultant from the Indiana State Library's Professional Development Office. I'll be the host and the question moderator for today's webinar, which is called Essential Astronomy for Libraries, and it's presented today by members of the Indiana Astronomical Society. We've got Ben Jansen, who will do the bulk of the presenting. He's the Vice President of the Association. And then we also have Laura Keller, who's the Secretary and Librarian, and Fred Keller, who is a board member. They will be assisting with the chat. A few housekeeping items before we get started. If you are having sound issues during the webinar, please see the sound issues box. It's just below the chat box on the left side of the screen. If there's a global sound issue, which means everyone is experiencing the same issue, we will announce it in the chat box. If you're individually unable to resolve your sound issues, though, rest assured that we are recording this webinar and you can watch it offline after it has ended. Again, if there's a global sound issue, we'll make an announcement in the chat box. If you have a question during this webinar, you can type it in the chat box there on the upper left side of your screen. Looks like many of you have discovered it already. That's great. I will be watching it, and I'll get to your question, or I'll get your question to our presenters as soon as there's a good opportunity. We will be saving a lot of the questions till the end, but Laura and Fred, like I said, will be monitoring the chat box with me, and they will answer any questions that they can as we go. Okay, the session today is worth 1 LEU, and your certificate will be available for download at the end of the webinar. If you're watching an archived recording of this presentation, information on how to obtain your LEU is in the video's description on YouTube. On a related note, today's webinar will be recorded and archived. After the webinar has been transcribed, it will be available on the Indiana State Library's Archived Webinars page. For weekly updates on upcoming trainings and to learn more about what's happening in libraries across the state, please subscribe to the Indiana State Library's e-newsletter, The Wednesday Word, and check our continuing education website for other professional development opportunities. All right, let's get started. We're going to pull up Ben's presentation here, which always takes just a moment. And then I think we should be good to go. So I'm going to go ahead and turn the presentation over to Ben Jansen, Laura Keller, and Fred Keller, all from the Indiana Astronomical Society. We are so happy to have you guys here today. So go ahead, take it away.
Glad to be here. Thank you very much, Beth. Thank you, Kara. So our presentation today, again, was created for educational purposes here by the Indiana Astronomical Society in partnership with the Indiana State Library. We're thrilled to be working with you folks.
It's still loading on my screen, so let's see. Let's try reloading it real quick. Sorry, guys. Technology. Try it one more time. There we go. Try it again. Yeah, there we go. Okay, we just need to pop this up. Okay, thank you everybody for your patience. Here we go.
All right, take two. So our program today was created in partnership with the Indiana State Library, and a big thanks to you all for your time today and for inviting us out. So the overall purpose of this program is it's really going to be a quick crash course. We're going to rush through quite a bit of content, but the purpose really is just to sort of help arm librarians with some practical observing knowledge to help you facilitate programs at your individual branches. And so what we'll really be focusing on is just objects that you may be able to see from the solar system and potential like deep sky objects. We're going to kind of go through just a couple basics of navigating the night sky, getting yourself oriented, and then we're going to actually show you how to find a couple of popular summer objects in the sky. So just try to provide some background there. So what are solar system objects? So for all intents and purposes, for visual observing, we basically refer to solar system objects as pretty much anything, within the sphere of influence of the sun, right? So we've got the planets, right? Moment of silence for Pluto. Sorry, it's still mourning that one, but it's all right. There's asteroids predominantly hanging out in the asteroid belt. There's comets and other materials in the Kuiper belt. And then there's just miscellaneous debris floating all over the place that produces meteors and things like that we can see in the night sky. So there are several easily observable solar system objects that are easily visible either naked eye or with small telescopes or even binoculars. And so obviously the sun and the moon, those are two big ones. Mercury, Venus, Mars, Jupiter, and Saturn are actually 5 planets that can be seen with the naked eye if you know where to look for them. So you don't even need an instrument or telescope to see these if you know where to find them. You can point them out, and it's definitely neat for crowds. Some other objects, obviously comets. Every once in a while we get a bright one that comes through. On a given night, meteors. Every day the Earth is hit with tons and tons of material. So depending on your luck, you could see one of these potentially any evening. Asteroids are a little bit tougher. You typically are going to need like a telescope to see them, but even with small telescopes you can see some of the larger ones. And then artificial satellites. These are actually pretty neat. A lot of times when you look up you can see solid pinpoints of light moving steadily. They're not blinking like an airplane. Those are actually satellites. Oh. And so this is actually a really neat call out too for folks. It's easy for people to see. And one big one is the International Space Station. This is a quick clip that I took in my folks' backyard. But a lot of times there's great apps and online calculators and things like that. But they'll tell you when the space station is going to rise, and usually the transit takes like 2 or 3 minutes. I think it's very bright. And so a lot of people have never seen that before, and it's pretty neat to think about a football field-sized object flying fast enough to go around the world like once every 90 minutes, passing overhead. So another great one to share with them. It's really easy for the public to enjoy. And then this is actually a clip. Fred and Laura actually captured this a couple years ago, right? Yes. Mm-hmm. There was an asteroid flyby, and it was a little harrowing and took quite a bit of effort on their parts, but they managed to actually capture.
Tell them about the off to the right, the fuzzy thing.
Yeah, and off to the right, if you see, that's actually a galaxy. I think that's M64. Is that right, Fred?
Yes.
Yeah. So basically, they took a time lapse here, and you can see the asteroid moving against the background stars there. So yeah. So. Deep sky objects. Deep sky objects are basically objects that are beyond our solar system. So other stars, right? And in terms of doing visual astronomy, we usually put these, think of these in a few different classes. So there's star clusters, there's nebulae, and then there's galaxies. So star clusters, sort of just like they sound, right, are clusters of stars that are gravitationally bound to one another. There's a couple of different classes of these. The first are open clusters. As you can see, they're more there could be dozens, like a few of them, to potentially a few hundred or thousand, but usually they're more sparse, they're more spread out, they have that kind of open appearance. Some of them literally are only a handful of stars, but some of them like this, are larger and more impressive. This is the double cluster. This is found in the northern sky. And can be seen actually in Indiana. It's pretty high up there right now. In the summer it'll be a little bit lower and won't be quite as prominent. But yeah, so these are thought to be younger than globular clusters just because the gravity's pulling them all together, but they're not quite bunching together, but they're still gravitationally bound. And usually they have a lot of hot blue young stars inside and things like that. So opposed to the open clusters, globular clusters are some of the neatest objects to observe visually because these things can contain hundreds of thousands of stars. And this image right here is it's Messier 13, the Hercules cluster, which we're going to show you how to find later. Because this is a prominent object up in the summer sky. In very dark skies, it's actually visible naked eye, almost, borderline. But this is an object that, because they're stars, with a small telescope, if you know where to look, you should be able to find this. It'll look like a little fuzzy patch, but it's still kind of neat.
Even with binoculars, you can see
this. Yeah, exactly. Even with binoculars, you can see it too. So these, again, can contain hundreds of thousands of stars. Messier 13 here actually is a collection of 500,000 stars all packed together.
Wow.
And these are theorized to be more mature groupings of stars, just because as time has gone on, they're getting pulled together. Some of them are theorized to actually have like black holes associated with them that are kind of pulling them together.
Oh, okay.
So those are the star clusters. So nebulae are vast expanses of gas, dust, and other material. And there's a couple different types of nebulae. This picture on the right is the Rosette Nebula, and as you can see, this is a massive expanse of gas and dust, and you can kind of see sort of where there's accumulations and the material is starting to kind of come together. Eventually, when it starts getting packed tight enough, you'll get nuclear fusion starting, and that's how stars are born. So yeah, nebulae they're essentially stellar nurseries. Now, this is kind of splitting hairs, but with these types of nebulae, there's like emission and reflection nebula. Emission nebula are technically those that are emitting their own light. There also are ones called reflection nebula, where they're still there and they are these massive clouds of gas, but they're reflecting the light of stars or other nearby objects instead of actually producing their own, just because maybe they're not hot enough. But these can span hundreds of light years and be just like massive. And these objects, the nebula that we observe in the night sky, are actually part of our Milky Way galaxy. So they're in our galaxy, as are the star clusters. That's kind of an important point.
Oh, wow.
So so M13, the open clusters, the double cluster, these are all star clusters that are in different parts of our own Milky Way galaxy. So in opposition to the emission reflection nebula, another type of nebula is what's called a planetary nebula. Now they're often round in appearance, but basically these are the remnants of stars that have died. This is a picture of the Helix Nebula that was taken by the Hubble telescope. And as you can see, there's actually a tiny, tiny central star in the very middle. But really what happened here is that this star at the end of its life went like red giant, and it sloughed off all of its outer layers and basically blew them out. And so that's what we see like right there. So planetary nebulae they typically are always remnants of stars that have died and either gone supernova and it actually exploded, or they've gone red giant and sloughed off layers like you can see here. Usually they're smaller in size than the larger star-forming nebula, but they can still span light years. Like I think that this right here is a couple light years in diameter. So they're still pretty big.
What's the cause of the different colors that we see?
So that is
that too complicated?
Yeah, basically they're different elements. So this type of imaging that's done by Hubble that's actually a great question. Hubble uses different wavelengths of light to capture detail. So there's specific wavelengths like hydrogen alpha or oxygen 3 that give off very distinct wavelengths like this kind of red and blue colors. And they use them so they can kind of see internal structures and things that aren't really visible with like visible light. And so it's kind of a false color image, but at the same time it allows to see the structure.
Right,
so
okay.
It's a great question. So galaxies. So for the most part, the clusters, right, and the nebulae that we can see in the night sky are part of the Milky Way galaxy. But there are also tons and tons and tons of galaxies that we can also see as well, even with a small telescope. There's typically 3 major classes of galaxies. So the spiral is probably one of the best known shapes, classes of galaxies. Our Milky Way galaxy looks fairly similar to this. Our sun is a star that's out on the outer arm of the Milky Way. There's elliptical galaxies. They don't have that spiral structure. They tend to be just more kind of dense, accumulations of stars, and those are still all stars packed in there. And it is like an entire galaxy. It's just the shape and the formation is a lot different. And there also are several known just irregular galaxies. They just have bizarre shapes. A lot of them are theorized to have been the result of collisions of different galaxies that the wreckage is just streaming across interstellar space. A lot of different theories for how those are formed, but ultimately those are the 3 major classes. In terms of galaxies, I mean, there's several that we can see. Even again, if you have dark skies in Indiana, there's 1 or 2 you can see like naked eye. The Andromeda Galaxy is our closest neighbor, but even our closest neighbor galaxies are still like 2 or 3 million light years away. So that means that when the light from those objects hit the back of your retina, it's been traveling through space for 2.5 million years before you finally see it. So actually, in a way, you're almost looking back in time. So it's kind of interesting to think. So those are galaxies. So the major part we want to get into now is, after just doing a quick recap, of some of the things that we can see, is just sort of navigating the night sky, and kind of orienting ourselves and just sort of understanding like what the motion of the Earth is doing and how that's sort of being reflected, and what we actually see and observe in the sky. So the first thing that's kind of interesting to note, which it seems like kind of a no-brainer, but some people are actually kind of surprised because they just haven't thought about it, is that the night sky changes with the seasons. So the stars that you're going to see in the summer, in the winter, in the spring, the fall, they're different. And the rationale for this is that you can kind of see here in this diagram that the Earth, right, the side of the Earth that's pointing towards the sun obviously is experiencing daylight, and the side of the Earth that's pointing away is experiencing night. So you can imagine that all of those stars that are off to the right there is what all those people on that side of the Earth are seeing in their night sky. So let's say that this is spring, for instance. So let's go all the way over now to autumn, and you can see that now the night sky that you were once able to see is now being dominated by the sun. It's daytime; you can't see it, and so there are now night is like totally diametrically opposed part of the sky. And so as the Earth, I'm sorry our videos are slightly wonky here, but you can kind of overall get the point. You can see that as the Earth basically moves through all the seasons, slowly, little by little, each night we actually start to get a little bit of a different view of a different part of the night sky. And as the seasons progress, we'll get new objects, we'll lose other objects, and then they'll come back around the next year. So similarly, the motion of the stars. Again, sorry, it's not supposed to be a flat Earth, I promise. But yeah, so the motion of the stars ultimately are caused by the rotation of the Earth. And so as the Earth, so the apparent motion, I mean, the stars are moving out in space, that's true, but relatively, I mean, they appear to be fairly fixed. Mm-hmm. So what you see on a nightly basis with the moving across the sky is actually the result of the Earth rotating, like we see here. So when we look up at our night sky, okay, this is looking sort of into the northeastern sky, we just saw how the Earth was rotating. The effect that we see then is this. And so you can see that Polaris there sits very, very close to the axis of the Earth's rotation, which is why we call it the pole star. And that's why it appears not to move, because everything else is apparently moving. Polaris is not, because it happens to be sitting right above that spot. But we can see that because of the rotation of the Earth, all stars are and other objects are rising in the east and setting in the west. So that's the reason for that apparent motion right there. So now we're going to move into showing you folks how to find a few things, so do some practical observing. This is probably one of the most common applications in the night sky, and a lot of people might know this one already. But one of the first things to do is we get our cardinal directions and find celestial north, right? So the first thing to do to find Polaris is to find the Big Dipper, okay? And a lot of people can do that, a lot of kids can do that pretty easily, which is awesome. The Little Dipper itself, the stars are a little fainter. So if we're in light polluted skies, or you're in an area that's more urban, it might be difficult to make out all the stars of the Little Dipper, but you should still be able to see the stars of the Big Dipper. And then ultimately then, using the Big Dipper, those two front stars on the very front, they form like a pointer. And for most adults, if you put your hand up in front of your face, outside under the sky, the distance between them is more or less about the distance from your outstretched thumb to the end of your pinky.
Oh, nice tip.
It's a little bit close. I mean, it'll vary, right? But it's fairly close. So that is how we find Polaris. Right there. And so the next thing, especially for summer observing, that would probably be really helpful is to talk about finding something called the ecliptic. So the ecliptic is this imaginary line in the sky, this arc, that actually represents the plane of the solar system. Because we saw earlier that the solar system is a disk, right, that's spinning. And, the Earth, however, because of our tilt, we appear, to have the disk is sort of also tilted up in the sky. And so the neat thing about the ecliptic is that the sun, the moon, and all the planets follow this line.
Oh.
And so, because they basically, once again, plane of the solar system. So, usually on an arc, like here in our northern latitudes, the ecliptic it's a little bit south of true east, just depending, but more or less, and we'll see the motion here. This is a speeded up graphic, but you can kind of see all the different planets, the sun, the moon, and how they ultimately live on that plane. So the cool thing about the ecliptic is if you generally know that there's this arc in the southern sky from generally east to generally west, you can use that to help you identify planets. And so that actually is going to bring us to our next topic. So in terms of observing, I know that a lot of you folks will probably be observing in different environments. Light pollution is definitely, an issue these days. It's difficult. Unless you really are able to get out of the city 45 minutes or an hour or so, it's tough to see, the Milky Way or to see some of these things. But we're going to try and cover a couple of different neat things that we should be able to see as well. So Jupiter and Saturn are going to be coming up. So this was supposed to simulate the sky on the 4th of July. So kind of right in the middle of the summer, right smack in the middle of like when all the programs I think should kind of be happening, just to sort of give you guys. So all the night sky elements that you'll be seeing from here on out are going to they were simulated on the 4th of July to hopefully be as relevant as possible to that time frame for you folks. So identifying Jupiter. To be honest with you, it's actually not that hard to find. It's pretty big and bright, and most people think it's a big, bright star. Honestly, it'll probably be the brightest object in the southern-ish sky. And so the first thing to do is just orient yourself, either using Polaris or using other means to get yourself oriented to your cardinal directions, find south. And if you look south, okay, you'll see this big, bright object shining very steadily, right, basically just east of south, okay, up there in the sky. And so in addition to using the ecliptic to kind of verify, like, hey, could this be a planet? Another big tip is that planets don't twinkle. So if you look at Jupiter and you compare it to the stars around it, even on a clear night, they'll still be shimmering a little bit, but the planets they're very, very steady, and so you can tell. Ooh. And then actually, on all of these ones where we're kind of doing some practical observing tips here, I actually have included like small images that were actually taken through small telescopes. So the little Jupiter that you're seeing down there in the corner, that's actually fairly representative of what you would see, like potentially in a small telescope. Now this has a little bit more detail, but even in a small 4.5-inch telescope, it's pretty easy to see some of the striations. You can see the Great Red Spot. Yeah, one of the really cool things that's really neat, especially if you have a larger scope and can put some power on it, is what they call transits, where you can actually watch moons moving in front of it, and they cast a shadow that appears like a little black dot that moves across the surface of the planet. So those are always like really neat. Every once in a while, like usually once or twice a summer, they have like double or triple transits or something crazy like that are pretty exciting for us. But the main thing about Jupiter is, in addition to the surface features there, if in a small telescope, you'll easily be able to see 4 moons going around it. So there's Io, Callista, Ganymede, and Europa. These are known as the Galilean moons because they were first identified by Galileo, who was one of the first ones to look at them. And he actually, there's programs that you can do to, like Laura's actually done, to sort of walk in the footsteps of Galileo and recreate his observations using small telescopes. But one of the things that he actually observed for the first time was he saw these dots around the planet Jupiter moving back and forth and back and forth. I mean, at that time, they still had a very geocentric picture of the universe. And so after a while, he basically came to the conclusion that, look, these things are moving around this other planet. They're not moving around the Earth. And it was obviously kind of a big deal.
Yeah.
But, so when you see the Galilean moons, just think astronomical scandal. But it's actually, it's really neat. So in a small telescope, they're very clearly defined, and they move night by night. So yeah, that's actually really neat. And this is something that even in a light polluted area, once again, you should be able to see. And it's definitely a crowd pleaser. A lot of times when we do outreach activities and things like that, I mean, people will line up to see, the planets, and it's something that they can see very easily.
And you can train your telescope on it. And
you can train your telescope on it. It's easy to find, and a lot of people have never seen it before, and you can see it from pretty much anywhere. You don't need super dark skies. So Saturn, similarly, Saturn is going to be a little bit further down at this time. As July progresses and the night gets darker and darker, Saturn will continue to get higher and higher in the sky. As you can see, it's actually right over here, just a little bit further east of Jupiter, sitting right there on the ecliptic. Saturn is going to be a little bit yellower than Jupiter. Jupiter will be more of kind of a bright whitish color. Saturn is usually typically a little bit like more yellow, but it'll still be bright. It won't be as bright as Jupiter, but it'll still pop out at your naked eye if it's truly dark. And so you should definitely be able to see that. So once again, I mean, if you're able to find south, look for the ecliptic, you find Jupiter, and if you see a bright object that looks, just a little bit down to the left of Jupiter, then you can tell it's probably Saturn coming up.
So in early June, would they probably not be able to see it very well at all, because it would be
in early June? Jupiter would probably be up, at Saturn probably. What do you think, Laura?
Later in the night, you would see it by now.
So this right here is set for like 10.
Okay.
So.
Which is a problem once we go to daylight savings time.
Right.
You have to be up fairly late to be able to see.
Yeah.
Yeah. In case you guys couldn't hear him, he was just pointing out with daylight savings time, it has to be at least 10 o'clock before it's probably dark enough to see anything. And so this is set for 10 o'clock. So.
Yeah. Yeah, that's the one thing about the winter is it's brutal outside, but it gets dark at 6 and we can start observing.
Right.
Whereas you got to wait till 11 o'clock in the summer before you can actually enjoy a truly dark sky. But yeah, so just for reference, again, that's another image. This is another one that was taken by us with a small telescope. This is a little bit larger than it might appear in an actual telescope, but it appears very similarly. You can vary, even in a 4.5-inch telescope, you can definitively see the rings sticking out. They almost look like little ears.
Oh, cool.
If you put a little bit of magnification on there, there's a line that runs circumferentially around the rings there. It's called the Cassini division. It's a gap in the rings there. Mm-hmm. Depending on the scene and the conditions, in the night, that's something that it might potentially be visible. But
seeing the rings of Saturn it's a real crowd.
Yeah.
She said seeing the rings of Saturn is a real crowd pleaser.
Yeah. Yeah, people, I mean, to be honest, especially if you have a large crowd, I mean, you could spend easily the entire night. I mean, if you were able to pick out a couple of satellites, if you get an International Space Station, pass, mm-hmm. show them Jupiter and Saturn, I mean, honestly, you could have a full night even just with those things.
I know a lot of professional astronomers have indicated that seeing Saturn's rings was the inspiration for them to become an astronomer.
Yeah.
Wow.
So the moon is another one, and but we'll take a peek at how to find a couple of other deep sky objects, but just to sort of round off, some of the main staples that would definitely be available on pretty much any clear evening. Well, the moon, it's not available every evening, but it's out enough that there's probably several evenings where you guys could do programs, and the moon would be visible. The moon is also something that's incredibly striking. If you've never seen the moon through a telescope, again, this picture right here was taken with a small telescope. So, I mean, it really does, I mean, it looks like that. So the moon rotates at the same rate that it revolves, which is why we always see the same face. We never see the far side of the moon. We always see the same face, like, towards us. The darker areas that you see on the face of the moon are known as mare. It's Latin plural of maria, which means seas, because a long time ago when they looked at them, they figured they must be oceans. Mm. These areas, if you notice, they look very smooth. and they have significantly fewer craters than the surrounding areas on the moon. They're thought that these are younger lava flows that may have resulted from impact craters or some type of seismologic event or something like that. But the bottom line is that these areas, I mean, they look very, very smooth and they don't have as many craters, so they probably are younger. Some of these craters that you see on the moon, they look small in the image, but they can be dozens or even hundreds of miles in diameter. So think about driving around, the rim of a crater the size of 465. It's pretty crazy, but I mean that's a pretty common thing up there. There's no atmosphere or weather on the moon, so there's no erosion. Footsteps that are left up there are still there. Craters from millions of years ago are still there, and they, unlike the Earth, there actually are lots of impact craters on the Earth, but because again of the atmosphere, the weather, the wind, the oceans, all of that action, they get eroded away, and so a lot of those get hidden. So moving forward, we're going to show you another couple of features. Now, a couple of the objects that we're going to point out here are sort of challenge objects, but are still potentially visible. So these are still very, very useful, and if you could find these, I mean, they're definitely findable, especially if you have a little bit of a darker sight, but these are some of the more popular summer objects. And the cool thing about this is, I mean, you can actually tell people like, hey, we're looking beyond the solar system, and we're actually looking at like star clusters, or we're looking at like planetary nebulae. So like the Big Dipper, there's an asterism, which is basically just means stars that make a shape. It's called the summer triangle. And the summer triangle, it happens to sit right in an area of the sky that's right on basically the plane of the Milky Way. So there's a lot of interesting stuff in this. So this is actually a very useful landmark to find, because once you go, you can use it to look for a couple of the things we're going to show you here, and you can use it. There's a bunch of interesting things in that area to find, like once you just do a little more advanced. Yeah. So the way that we find the summer triangle is, once again, you can see this is about at 10 o'clock here. In the southern sky, we found Jupiter, right? We found Saturn. The summer triangle is actually right here, and it's made up of 3 stars called Vega, Altair, and Deneb. And they actually sit right here on the constellation Cygnus as well.
The Swan.
The Swan, exactly.
Yeah, go me.
That's right.
Sorry.
Bonus. No. Yeah, so Cygnus the Swan right here. Again, tons of stuff in this area. But the summer triangle, I mean, people love looking at constellations, finding the Big Dipper. The summer triangle is one that it's very prominent. The stars are very bright. You should be able to see them even, in an area that's fairly urban. But it will be a new one for a lot of folks that's pretty neat. And again,
this image is not quite apparent, but it tends to be almost overhead.
Yeah.
Rather than on the horizon like it looks like in that photo.
Yeah, it's more like if we go back. Good point, Fred. So right here, you can see in this photo, it's a little bit blurry, but the images that I'm showing you from the planetarium software, they are distorting it a little bit. So Fred's correct. It'll appear more like this up in the sky. So the location of this, though, it will be east of Jupiter and Saturn, though, in the sky. So if you found, south, you found Jupiter, basically you're going to be looking like up and left of Jupiter for the summer triangle. So now Albireo, this is another one that it could be pretty easily findable for folks even in urban environments. You don't need super, super dark skies to see it, and through a small scope, this is actually kind of a neat object. Albireo is what's known as a binary. Now, true binaries are stars that actually orbit one another. And Albireo, the jury, I guess, is still kind of out because there was some dispute about whether this was a true binary, like these 2 stars orbiting one another, or whether it's only an apparent binary, like they just happen to be close in the sky. It seems like the skeptics may have won out. It may be only an apparent binary. Still really cool to see because there's a super bright blue and orange star sitting right next to each other that are pretty bright. And through a scope, it's just another neat thing that you can show people that they've probably never seen before. So the way that you find this is we identified the summer triangle of Altair, Vega, and Deneb. And Albireo is sitting right here inside the summer triangle. And so Using the finder on the scope, the telescope, you should actually be able to point it right to the star that you should actually be able to see visually. And looking in the field with the scope, again, you should be able to see the bright blue and orange star. So we wade further into challenge territory here. So if you can find this is super cool. And the next one as well. And I mean, even if you're not able to do this for a program, try it yourself sometime because you're going to get addicted. It's pretty awesome finding some of this stuff. So the Dumbbell Nebula is actually in the Summer Triangle. And this is a planetary nebula like we talked about. That photo up right was actually taken at Fred and Laura's observatory. Once again, short exposures. This is a planetary nebula, so it's a remnant of a star that basically blew itself apart. And when you can see it even in a small telescope with reasonably dark skies, and it actually will look like this fuzzy. No, it won't have quite this much detail, but you can still tell it looks like a fuzzy hourglass. And so the way that we find the dumbbell, and the first time you try it, it might be a little tough, but once you find it and you know where to find it, it's like riding a bike. All of this stuff like star hopping and things like that, once you find your landmarks and you get established, you can find things pretty easily. So the quick and easy way to visually just identify the area where the dumbbell is at is you find the Summer Triangle, and then you kind of see there's these 3 stars here in a row, and they're a little bit brighter than the surroundings, so they're typically pretty easy to pick out if you have a dark enough sky. And then the dumbbell sits right there off of those 3 stars. So again, I would find those 3 stars and just go a little bit off in this general area and just kind of scan that area with your eye on the eyepiece. And that's where you probably would be able. That's where you'll be able to find it. And so the dumbbell is otherwise known as M27. A lot of these objects have different categorizations and numbers and things like that. M stands for Messier. Charles Messier was a Frenchman, and he was a comet hunter, and that was all the rage back in the day. It still is, but the interesting thing was that these guys were identifying a lot of things they thought were comets, but really ended up being galaxies or star clusters or planetary nebulae like these. So the interesting thing about the Messier catalog is they're the 110 pretty much brightest objects in the sky. So when you start doing real astronomy, they're some of the first objects you look at. But the thing that I think is kind of funny about them too is that the guy recorded these so that other people wouldn't try to claim that they had discovered new comets. So it's technically the French not comet list, but it's a neat list of lots of different galaxies, clusters, nebulae, and things like that. So that's what the M means. So M27 is the Dumbbell Nebula. And so the last one here that we'll show is the Hercules cluster. So when we talked about globular clusters earlier, we actually showed this picture that you can see in the upper right. Like once again, this is a cluster that's composed of about 500,000 stars. And because these are stars, it's a little bit easier to potentially pick this one out in a not super dark sky. This is almost naked eye if you get out to a dark site. I mean, I've seen this naked eye before, like about an hour or so outside of the city. But with a small telescope and a decent skies, not too much moon, not too much light pollution, this is another one that you should be able to see. And when people see this kind of thing for the first time too, this is also a real crowd pleaser. Like people will be swarming the eyepiece to see this, just like Laura mentioned, like with Jupiter and Saturn. So the way that you find the Hercules cluster is we're looking at a familiar piece of sky here, right? We have Jupiter, right? We have the ecliptic there. We're looking basically towards the south. We have the Summer Triangle here on the left, right? Now, this is slightly distorted, but just, in order to get everything in the viewpoint, we had to do that just a bit here. But what you do is you look up and to the right from where you're at in the Summer Triangle, and there's a formation that's kind of known as it's like the trapezoid. Okay, this is the breastplate of Hercules up in the sky, and that cluster is located between those 2 stars of the trapezoid right there. Again, if you start off scanning that corner star and you just move slowly over with your eye on the eyepiece, it actually shouldn't be too tough to find. It'll when you see it, it'll pop out at you, and it won't look potentially quite as resolved as the photo, but you should definitely be able to see like some of the outer stars, and the core of that, it'll look like just like a fuzzy, like a big fuzzy smudge with like a ton of peripheral stars all around it.
It's also visible in binoculars. It's
Yeah.
fuzzy spots in that same location.
Yeah, Fred brings up a great point. Both of these are visible in binoculars. So the Dumbbell Nebula, same thing. Go outside on a dark night with a pair of binoculars, you can easily find that. That's a great point.
And we actually just had a question. They asked, what type of binoculars would you recommend for stargazing? We'll collect all this information and put it in a document and make it available. I'll send it out to you guys with the recording that I'll send to everybody who's signed up, and I will post it on the archived webinar page so that it'll be accessible there as well.
We could put it on the NASA at My Library website.
Yes, yeah. We have a NASA at My Library website that we are in progress putting together, and we will add it there as well.
In terms of other resources too, the software that was used to this planetarium software is called Stellarium. This is absolutely free. You can download this. You can turn anything on, anything off, find anything you want. This can be found at stellarium.org. We'll have that posted as well. There's several good pieces of software for your mobile phones these days, though, to be honest, and a lot of them even have augmented reality and all kinds of other crazy features. And a lot of them also have satellite rise times built in. So a favorite amongst some of us more serious folks is Sky Safari. They actually have several versions. They have a basic version that's free. They've got an upgraded version that's like maybe a couple bucks, like $3-4. It's absolutely worth every penny because, I mean, it'll show you everything that you could possibly want to find. It'll tell you where to find the ISS, when it's going to rise, and give you alerts for different things like that. And you just point it up at the sky, and it'll basically like help show you what you're looking at. So it could be a really useful tool when doing public presentations and stuff. So, yeah. Well, yeah. But that was about all that we had. in terms of the content that we had, but we'd just like to throw it out for any other questions or discussion that anybody might have about anything.
We have multiple attendees typing, so I don't know if they're all just saying thank you or if they have questions. So we'll give them a moment. You guys, in the meantime, while we're waiting for questions, here. Could we get a couple of book recommendations for beginners?
Librarian.
We'll come up with that and give you a little.
Okay, great.
Sorry, Laura.
It looks like we have another question from Dawn, but before we ask that, because a few of you, it looks like you're wrapping up and thanking them for coming. As we do that, I'm going to pull up the LEU sheet. So on this page, you can go up to the very top to the LEU file share. You will click on the Essential Astronomy Webinar LEU certificate, and then you'll hit Upload File. And you might have to give your computer, you might have to say yes to a couple of things to give it permissions, and then you should be able to download it. The other thing to note is down the third box in the middle here, it says Survey Link, and then it says click here, and then click on Browse to below to complete the evaluation. So if you click on those words, then the link will pop up in that Browse to, and you'll click Browse to, it'll take you right to the survey. But now it looks like we do have a few more questions. Looking for more info, yeah. A central listing for astronomy clubs, and Don, also, in addition to central listing for astronomy clubs, there's also the Night Sky Network and the Solar System Ambassadors. Both of them have websites. Those are people who will come and do free presentations at your library, potentially. You just go to those websites, you Google them, Night Sky Network and Solar System Ambassadors, and you enter your zip code or whatever, and you find people who are close to you. But we will add those to the list also. Debbie wants to know if there are any websites you can use in programs that show different night sky items, so we can also do a list of those.
There's a number of links off the iasnd.org too.
iasnd.org. Thank you. That's great for people who wanted to get started right away. I think that was all of the primary questions. So most of it is for resources that we will put together in a document for you guys. Any other questions, guys?
And if you guys have any other questions, feel free. I think you're going to provide my email address.
Yes.
And if you go to the ias.indy.org website, there's a list of contacts too. So feel free to reach out with any questions about anything. We'd be happy to help you.
At the very bottom, in the middle of this page where I have your LEU and the survey, there's also presenter contact information. So there's my email address. You can always email me, guys, and I can direct you to whomever. Or you can directly email Ben at the Indiana Astronomical Society. That's who's been presenting for us today. He's the vice president, and that is his email address right down there in that box. All right, looks like we have mostly just thank yous and great presentations. And so
thank you guys once again for having us. It's awesome to be here.
Thank you. I want to thank you guys for all your time and great information. So good luck, everybody, with your summer reading